Hello and welcome back. In this video, we shall see LCR series circuit. So, in case of LCR series circuit, we have inductance, rather this is inductor, then we have capacitor, and then we have resistor, all of them are connected in series. So, this inductor we will call it as capital L, capacitor is capital C, and resistor is capital R. Now, their values their values we have to take here. So, on this kit we have different values available. For inductor I will take capital L is equal to 30 millihenry, then capital C is equal to 0.1 microfarad, and capital R is equal to 100 ohm. Now, we have to study LCR series circuit here. So, we have to connect all of them in series, and then we have to connect it to AC supply. For that we will be using a function generator which will give sine wave input, and then we will connect it to a milliammeter to measure the current. So, in this way our circuit will be connected. So, I will just connect this circuit over here. So, for that purpose I need these pins. So, this, now see here, this is the multiplier 1 and this is common. So, I am using multiplier as 1 here and common means the other point. So, I will connect this common over here again. Okay. Now, from this function generator I will connect it to inductor capital L. So, you can show it here. This is 30 millihenry inductor. So, I will connect it here. Then the next point of the inductor I will connect it to capacitor. So, this is 0.1 microfarad capacitor, and the second point of this capacitor I will connect to this resistor, 100 ohm resistor, and the other point of the resistor I will connect back it to milliammeter, and this, the next point of the milliammeter I will connect back to the function generator again. So, yeah, it is working now. Now, I will show you how to adjust this function generator first. Now, remember here L, C and R, we can connect them in any order. That means what, we can connect L first, C second, R, but one thing is that all of them should be in series with each other. So, now I will show how this function generator is working of this function generator. So, in this function generator we have, first of all, these two are the multiplier. This is the common point, and multiplied by 1 and multiplied by 0.1 are the multiplier, and we have this amplitude knob. So, we can increase or decrease the amplitude of the waveform with the help of this amplitude knob. Then these buttons, they are nothing but what? Frequency multiplier. That means whatever is the reading there on this dialer scale, that will be multiplied by these multipliers. So, say for example, if I put this on 30 here and the multiplier is 100 here. So, this is pressed here 100. So, this means it is 3000 hertz. That means it is 3 kilohertz. If the multiplier is 0.1, it will be 30 multiplied by 0.1. That means the frequency is 3 hertz. If multiplier is 3, if multiplier is 1, then it is 30 multiplied by 1, that is 30 hertz. Similarly, if it is 10, then it will be 300 hertz. And here if we put it at 100, then it is 3000 hertz, that is 3 kilohertz. And if I put the multiplier on 1K, it will be 30 kilohertz. Okay? And these are the different waveforms we can give as the input. We have sine wave, we have pulse, then we have triangular wave, sawtooth wave, and square waves. All these waves are possible with the help of this particular function generator. Now in this case we are going to use sine wave, so I had put this on sine wave and the multiplier is 100. Now you can see that when we vary this dialer knob of the function generator, then the reading in the milliammeter will going to vary here. Okay, so we have to note down this. So for this purpose we have to make a table here. So this table will have first serial number, then we have frequency in hertz or kilohertz, whatever may be. So I will put it in hertz, and we have current, capital I, in milliampere. Then there will be 1, 2, 3, 4 and so on, like that there will be readings. So here we will take these readings. Now see here, you can see this dialer is on 10 now here. Dialer is on 10 and this multiplier is 100 and we have given sine wave. So we are in this experiment we have to don't change this sine wave. Okay. So this is multiplied by 100. So this will be 10 multiplied by 100, means 1000 hertz is the input frequency. Hertz, that is 1 kilohertz of course, is the input frequency. And you can see this milliammeter reading here. So it is 1.2 milliampere. You can show this one. So this milliammeter reading is 1.2. So I will just note down it here on the paper. So it is 1.2 milliampere. Then I will just change this reading further. Say I will make it to 20. So this dialer is 20. That means what? This reading is 2000 hertz. And for 2000 hertz, actually this reading is increasing very fast. So we will increase this slowly actually. I will keep this dialer on 15 first, say. I will just cancel this reading. I will keep this on in between points. Yeah, I will keep it on 15 now. So for 15 you can see we are getting this reading as 2.2. So it will be nothing but 1500 and we are getting this reading as 2.2. Then we have to further increase these readings. So then what will happen if you go on increasing these readings? So these readings will go on increasing, and if further increasing the frequency, they have to decrease after a resonance frequency. So I will make it at 20 now. So for 20, that means for 20 multiplied by 100, so it is 2000 hertz. So for 2000 hertz we are getting it as 2.7. You can show it here in the milliammeter, 2.7. Now the next reading I will again increase this, say to 2500. So for 2500 we are getting this reading as 3.4. You can show in the millimeter. We are getting it as 3.4. Now again I will increase this. So it is now 3000, fifth reading. So for 3000 you can see that we are getting here 3.4 or so, 3.4 or 3.5 like that, 3.5 approximately. Now I will again increase this. Now this is 3500. So sixth reading 3500. For 3500, see here you will be getting here as 3 milliampere. So I will just write down it here, 3 milliampere, that is 3.0 rather, okay. Then seventh reading we will take for 40 multiplied by 100, that is 4000. So for 4000 you can see we are getting this reading as 2.2 milliampere, 2.2 milliampere. Now next I will make this reading as 45 multiplied by 100, so it is 4500. 4500. For 4500 we are getting it as 2.2, rather just 2.1 it is there. So I will write down this as 2.1. Then next reading I will further increase this to 5000 hertz. So for 5000 hertz we are getting it as 2.0. Then I will further increase it to 5500. For 5500 we are getting here as 1.8. Then I will further increase this to 6000. For 6000 we are getting here as 1.6. Then I will further increase this knob. So this is 6500. For 6500 we are getting it as 1.5. Then I will further increase it to 7000. For 7000 we are getting this reading as 1.4, you can see in the millimeter. Then I will further increase it to say 7500. And for this 7500 we are getting this reading in the millimeter, you can show sir, millimeter, we are getting it as 1.2 rather 1.2. Now you can observe this table here. When you can observe the table here we can see that as we have started this frequency from 1000 hertz. Of course we can call them as 1 kilohertz, then 1.5 kilohertz, like that also. So we have started from 1000 hertz. So the current reading goes on increasing, and at a particular current, say at this current 3000, there is a resonance. That means what? We are getting a maximum peak current in milliampere, and then there is further decrease in the current. So that you can observe here. So with the help of this observation table, we have to draw a graph here. So I will just draw this graph here. So you have to draw a graph of current capital I in milliampere versus frequency in hertz, or even you can take kilohertz also. Say if you want, you can take it as a kilohertz. I will write down here K, kilohertz. So these kilohertz readings will be nothing but what? From here it will be 0, say then there will be 1 kilohertz, then we have 2 kilohertz, 3 kilohertz, 4 kilohertz, 5 kilohertz, 6 kilohertz, 7 kilohertz and 8 kilohertz, because we have to go maximum up to 7005 kilohertz, and in between them there will be, this will be 1500 hertz, that is 1.5 kilohertz, this will be 2.5, this will be 3.5, this will be 4.5, this will be 5.5, this will be 6.5 and this is 7.5. Now you have to plot these readings I versus the frequency. So you will get a graph of bell shaped graph, that means you will get a graph like this. Okay, so you will get a graph of this type. Now here what you have to do is, you have to note down this maximum peak value here. So we will call this maximum peak as Imax. And then you have to divide this Imax by root 2. Now dividing this Imax by root 2 is same thing as multiplying it by approximately 0.7 times Imax. Okay, so whatever you get, this value 0.7 multiplied by Imax, you have to find out that value on this y-axis, and from that point you have to draw a straight line here. Now this straight line will cut this curve into at 2 points. Okay, then first thing we have here, from this center part maxima, you have to draw a perpendicular on what? Frequency axis. Then this point will give us FR, that is resonance frequency by graph. Then these 2 points we have to draw perpendiculars. This is nothing but our F1 and this is nothing but F2. Then you have to find out this particular frequency. So the resonance frequency by graph, is nothing but what? FR, whatever value you get there. And the bandwidth you can find out. Bandwidth is nothing but mod means you have to take positive value here, F2 minus F1, and this will give us the bandwidth. Now there are other calculations, that is the other theoretical calculations. So for theoretical calculations you have to use the L, C and R values there. So you have to use the L, C and R values there, which we have already noted down here. You can see that L value you have to use it as a 30 millihenry. So what you have to do is, you have to convert them into standard units. Say L is equal to 30 millihenry. So you have to convert it into Henry. So it will be equal to 30 multiplied by 10 raised to power minus 3 Henry. Then C is 0.1 microfarad, which is nothing but 0.1 multiplied by 10 raised to power minus 6 farad, and the resistance is capital R is equal to 100 ohm. Now these values you have to put in the theoretical formulas, and you will get all the theoretical calculations. Now in this way we can do these theoretical calculations, and also we have done this practical calculations also. You can take the screenshot of the readings and you can find out these practical results, as well as you can do the theoretical calculations. I hope that you understand this LCR series experiment in a better way, and if you like this video, do like, subscribe and share and comment also. If you have any difficulties, you can comment there. I am very much thankful to all of you for your support, and especially I am thankful to Dake sir for arranging and helping me in recording this video. Thank you very much.